Okay, let's test these graphs for power function behavior for exponential behavior. Now, it doesn't make any sense to test this one for exponential behavior since the graph goes through the origin. And you should understand why, but that's generally simply something that's true. Okay, so I'm going to take a pair of x values that double. So here is a good x value, and if I double it, I get out to about here. So let's see, between here and here, what are my y values? Well, this and this. Let's see by what factor this appears to exceed this. Just going to estimate it. We're not going to construct it. I could construct this length and then this length again. And you see I would somewhat, I'd be a little above the graph, so we see that the value hasn't doubled. Okay? Now if I take half of that interval, this interval here, I'm going to end up about here, so clearly the graph is increased by a factor of more than 1.5. I'm going to say the y factor it looks to me to be about 1.7. Of course, I could make more refined estimates of that. Later on, when we deal with numbers, of course, we can see what the y factors are. Okay, now, I'm going to choose two other doubling x values. Let's see, I'm going to go out to here, and I'm going to take half of that value. Well, you know, midpoint between here and here, it's not here, it's a little to the left of this. So I'm going to take this. Now I'm going to put a couple of arrows here to indicate that I'm comparing this value to this value. These are the two x values. Now I'm going to compare the values here and here. So if I go up to the graph here, I get something like this. If I go up to the graph here, I get something like this. It might have been a little too far to the right there. Now let's see what the y factor is between here and here. Okay, so let's see, the y value is here. If I come over here, there's the y value. I can kind of mark that. And if I come up here, y value would be way up here. If I cut this interval in half, I get a y factor of 1.5, which is going to be maybe a little above the graph. So I'm thinking the y factor here (1.4). Now, if that holds up, not very consistent. With the idea of a constant y factor. Now I can come down here and test this graph. Okay, well, just for convenience, I'll check, well, I'm not going to do that. I'm going to check, I don't have to use the same pairs of x values I used up here. I'm going to check this graph between, let's say, here and the doubling of that, which appears to be about here. Okay, so here's my original y value. My y factor here, well, it's clearly less, so the y factor is going to be less than 1. This y value is less than this. And if I cut this down to half, I'm going to be about here. Let's see, half. That's not too far off. So it's greater than half. So I'm going to say that's about 0.7. That's between here and here. And these are doubling y values. Now, let's just take a bigger y value. Let's go out here and we get a y value. And then let's go halfway between here and here, which might be about here, and we get a y value. Now, what's the factor by which y changes from here to here? If I go from here to here, well, my y value is here. Half of that, well, it looks like about half. That's probably not consistent enough. This is probably not a power function. Now, you should be familiar with this process, but that should just clarify it. What about exponential? Okay, let's find a couple of y values that have rather than doubling. And what kind of color chalk can I use here? Okay, I'll do that in purple since I don't have much purple here. Okay, so let's say here's a y value, and right here is the associated x value. Okay, now we cut that y value in half, we get down to about here, and my associated x value is about here. So the doubling displacement, if we have a consistent doubling displacement between here and here, is the difference between these x values that correspond to having two y values. Okay, so it appears that that's a doubling displacement, except that I did something really careless and drew that with the arrow in the wrong direction. As we hopefully know, between this x value and this x value, the y value didn't double, it cut in half. So really, I have to go from this x value to this x value in order for the y value to double. So that would be my doubling displacement. Now, we don't necessarily have to take half of this value, but I'm going to. Okay, take this and get the x value here, and this would be the doubling displacement. Now, this arrow looks a little shorter than this one, so I'm getting a little uncomfortable about the hypothesis that this is exponential. So I'm going to cut this y value in half again, come over here and down to here, and now I get this. Now, I've got to compare these doubling displacements a little more carefully. It looks plausible that the 3 points here actually fit an exponential function. But, of course, this isn't an exponential function, but that's okay. So that should illustrate the test, and people have been using the test. You want to use it carefully. And we get inconclusive results here, but if anything, these 3 points appear that they might well lie on the graph of an exponential function.